We are picking up where the video left off, and we're going to talk about when a relation is a function. A relation can be a graph, an equation, or a set of ordered pairs that's a function if every input or domain value, or x value, corresponds to only one output or range or y value. For example, if x equals 3 is in the domain of the function, then there may be only one ordered pair with an x value of 3. In other words, 3 can't correspond to more than one y value. Let's take a look at example 4, and we have in A a set of 3 ordered pairs. 0 as an x value corresponds only to 5, 1 corresponds only to 5, and 2 corresponds only to 5. That means that this is a function, and the justification for that is each x corresponds to only one y, or output value. In B, we see that the x value of 2 corresponds to a y value of 5, or an x value of 2 corresponds to a y value of 4, or an x value of 2 also corresponds to a y value of 3. So this is not a function because x equals 2 corresponds to y equals 5, 4, or 3, which are more than one value. In C, if I look at what x equals 4 corresponds to, 4 corresponds to a y value of 0 only. However, if I look at the y value that 0 corresponds to, 0 corresponds to a y value of 2, or also to a y value of negative 2, so this is not a function. And the reasoning is x equals 0 corresponds to more than one y value. In D, if I pick an x value, for instance, x is equal to -1, it corresponds to a y value of -2. If I pick x equals 0, it corresponds to a y value of -3. 1 corresponds to a y value of -2, and so on. And I think we can see in this graph that this is a function because for each x value, it only corresponds to one y value. So each x corresponds to only one y. When we're given a relation in equation form, like y equals 2x, I suggest that we look at a table of values. For instance, when x is -2, y has to be 2 times -2, or -4. When x is -1, y has to be 2 times -1, or -2. When x is 0, y is 2 times 0, which is 0. And when x is 1, y is 2 times 1, which is 2. When x is 2, y is 2 times 2, which is 4. When we multiply each x value by 2, it's only possible to get one result. So this is a function because there's only one y for each x. Let's create a table of values for f, which is y squared equals x. Now this equation is solved for x, so it would be a good idea for us to plug in y values. So let's plug in 0. If y is 0, then x equals 0 squared, which is 0. If y is 1, then x equals y squared, which is 1. If y is equal to 2, then x equals 2 squared, which is 4. And it would seem at the surface that this is a function because we're only getting one y for each x. However, if we are careful to plug in some negative y values, then when y is negative 1, x equals negative 1 squared, which is positive 1. And you'll notice that x equals 1 has two y values. So x equals 1 corresponds to two y values, or more than one y value. So this is not a function. There's not just one y value or output associated with each x or input. And that brings us to the vertical line test. Vertical line test is a really quick way that you can determine if a function is, if a relation is a function, if you have it in graph form. And that is, if no vertical line can be drawn so that it intersects a graph more than once, the graph represents a function. Let's take a look at a vertical line that goes through this graph. That intersects in one point only. I'll draw another vertical line. That one intersects in one point only. And another vertical line. This one intersects in one point only. And it turns out that no matter where I place the vertical line, it's going to intersect in one point only. And so this is a function because it passes that vertical line test. In B, we can see that if we place a vertical line in that orientation right there, we're going to see that we intersect with 2 points. So this is not a function. More than one y value associated with each x value. Now we're going to use function notation. And to get introduced to function notation, a function expresses the dependence of one measure on another. So f depends upon x is written in the following form, f of x. Now when we say f of x, it is not f times x, so no multiplication is implied here. Parentheses, nor the fact that the f and the parentheses are sitting next to each other, neither one of those things implies multiplication. In context, we need to understand that this notation refers to a function and not multiplication. So if I have an equation y is equal to 2x squared plus 3x minus 7, we can write it in function notation by re-expressing it as f of x equals 2x squared plus 3x minus 7. So really, f of x takes the place of the y variable. Now it is important that f of x is defined as equal to something, so if in B we do not have the equation solved for y, we'll need to solve for y first. So I'm going to subtract 3x from both sides, and then divide through by negative 6. Negative 3 divided by negative 6 is positive 1/2. And 12 divided by negative 6 is negative 2. So if we express this in function notation, f of x is equal to 1/2 x minus 2. If I want to find function values, that will be something that we'll use our equation for. So I'm going to recopy this equation in the next example. G of x is what we're told is that's equal to 3 times x minus 2. And we are being asked to find g of negative 2. You'll notice what happened is we replaced the x on the left side of the equation with negative 2. And what that means is we are going to need to replace the x on the right side of the equation with negative 2 also. So g of negative 2 is equal to 3 times negative 2 minus 2. And now we just need to do the rest of the arithmetic. G of negative 2 is negative 6 minus 2. And g of negative 2 is equal to negative 8. That's our final answer. And it doesn't mean multiplication, so we're not going to divide through by negative 2. what it points out here is that -2 is our x value, and -8 is the output for the function, which is our y value. In the next example, we were asked to find g of 0. So 0 is a replacement for x, and on the right side of the equation, we're going to take and replace the x value there with 0 as well. Same equation, g of x equals 3x minus 2, so g of 0 equals 3 times 0 minus 2. So g of 0 is equal to 0 minus 2, or g of 0 is equal to -2. Again, what this means is when x is equal to 0, y is equal to -2. This is actually just a little bit more descriptive than using plain y equals notation. If I replace x with m, then g of m is equal to 3 times m minus 2. As it turns out, there is no other operation that can be performed on the other side of that equation since we don't know the value of m, so we have to leave the unlike terms 3m and -2 uncombined. In 8, we have a quadratic function, so f of x equals x squared minus 1. So I'm taking and replacing the x with -3 if I want to find f of -3. So that will be -3 squared minus 1. And -3, when we square it, we get a result of 9. And so f of -3 is equal to 8. F of 0 is equal to 0 squared minus 1, which is 0 minus 1, or f of 0 is -1. These are all giving us x and y values that we could plot on a graph. For instance, if I were to try to plot a graph of this function, I would plot the point -3, 8 and the point 0, -1. If I want to find f of a minus 2, we'll do the same thing that we did with f of 0. When we found f of 0, we replaced x with 0. So for this expression, we're going to replace x with a minus 2. So a minus 2 squared minus 1. Be careful here, we don't distribute exponents over subtraction. So to square a minus 2, you must multiply a minus 2 times a minus 2, which when we FOIL gives us a squared minus 2a minus 2a plus 4 minus 1, or f of a minus 2 is equal to a squared minus 4a plus 3. That's our simplified form with all of the factors multiplied out and terms combined if possible. In the next example, we have a rational function, and a rational function is a function that has a ratio or fraction form to it. We can follow the same procedure. H of -1, that means we're replacing all of our x's with -1, and that gives us -1 divided by -3, or h of -1 is equal to a positive 1/3, since a negative divided by a negative is a positive. And then h of 0 will be 0 over 0 minus 2, or 0 divided by 0 minus 2, which is 0 divided by -2, and 0 divided by -2 is 0. Make sure that you simplify that fraction. We don't want to leave the fraction as 0 divided by -2. The fraction needs to be simplified to a whole number 0. H of 2 will be 2 divided by 2 minus 2, which is 2 divided by 0, and division by 0 is undefined, so h of 2 is undefined. When we look at functions in graph form, we can do the very same thing, find those function values, and remember that we talked about in the previous example that 2 was a replacement for x. So whatever goes on the other side of the equal sign after f of 2 is the y value that corresponds to x equals 2. So for the graph of f of x, f of 2 is equal to the y value of 3 because of this point 2, 3 on the graph. Now we're going to find g of 0, and g of 0 says that 0 is a replacement for x, and when x is equal to 0, the point on the graph that indicates a correspondence is 0, 1, so g of 0 is equal to 1. When we look for g of 3, let me back up here. I made a mistake, and it's something that you ought to be careful about too. I'm going to back up to example B. In example B, we were asked for g of 0. I wasn't paying attention, and I found us f of 0. It's important that we look at the correct graph, so we're going to look at the graph of g of x, and g of 0 is in fact -2. Because the point 0, -2 is on the graph of the function y equals g of x. To find g of 3, we'll also look at the graph of g of x, but this time we'll look as x is equal to 3. So when x is equal to 3, we can see that the graph has a y value of 1, so g of 3 is equal to 1. And then lastly, we'll switch back to function f, and for function f, we're trying to find f of -1, so I'll go to x equals -1 on the graph, and that point is -1, 0, so f of -1 is equal to 0. Now, in the next example, find all x values for which f of x is equal to 3. We're doing the opposite. Now we have what's on the other side of the equal sign, which is the 3. That's a y value, and we're looking for the x values. So we're looking to find f of what is equal to 3. Here's a point on f of x that has a y value of 3, the point 2, 3. So the answer to this is that x is equal to 2. In f, we are looking for the x values for which g of x is equal to -3. So that means we're looking for where y is equal to -3. And there's a point 1, -3 on the graph, so it looks like x is equal to 1. Now here's a variation. In part G, we're looking for all the x values for which f of x is equal to 1. And there are actually more than one of these values. So what I advise you to do on something like this is draw through f of x a line that has all points on it that have a y value of 1, and notice that it intersects with the graph 3 times at x equals -2, 0, and 3, and so there are actually 3 answers to this one. For our last example, here's another function called h. The other neat thing about functions is that we can name them differently. If they're not all y, then sometimes a function can be f, one can be g, one can be h. We can refer to them more easily that way and differentiate between the two. So for this function, h of 2 is indicating that we want x to be 2, and we're looking for the y value. So h of 2 is equal to -3 because the y value is -3 when x is 2. Now let's find h of 7. H of 7 is -9 because when x is equal to 7, the y value is -9. Lastly, h of 8, what you'll notice here is that if we go to x equals 8 on the x-axis, and then we go down and try to find a point on the graph, there is none there, which means that h of 8 is undefined. It hasn't been defined by this graph. And now we have the variation where we have the y value is -1, and we are looking for the x value. draw a horizontal line with a y value equal to -1, and we can find out that x is equal to 3 corresponds to y equal to -1, so that's the x value for which h of x equals -1. In f, find all x values for which h of x is equal to -5. So I'm going to move my horizontal line down to y equals -5. And we'll notice that we have 2 intersection points here, so there are 2 solutions. X is equal to 1 and x is equal to 5. And lastly, find all x values for which h of x, or y, is equal to 1. So y is equal to 1 is way up here. And you'll notice it does not intersect with the graph. So there are no y values, or you could even say no solution, because we're trying to solve an equation here that has no solution. There is no value of x that makes this equation h of x equals 1 a true statement. And that's it.